I would like to spend a few words to talk about the prolonged record North Pacific warming that was experienced between the winters of 2013-14 and the last winter 2014-15. I also would like to address the question of whether these type of warming events are going to become more frequent under greenhouse forcing. Now, to begin with, I'd like to look at the pattern and amplitude of the anomaly during the winter of 2013-14. This pattern is shown here in this map of SST anomaly, and shows a big kind of mass of warm anomaly here in the North Pacific, which Nick Bond has termed the blob. And what I'd like to show now is the evolution of this anomaly with time. So by the fall of 2014, the shape of the anomaly has changed and has kind of reached the coast here of North America, and has also developed a loading here in the tropical Pacific that resembles a little bit the El Nino, and in fact last year it was a weak El Nino. And then when we transition to last winter, the 2014-15, we see that the warm anomaly is amplified again, and again it's more located along the coast of North America, but also, it extends further in the ocean. Now, if we look at these patterns of the anomaly from the winter of 2014 to the one of 2015, we see that these patterns are not unknown and are connected to well recognized patterns of North Pacific decadal variability, and so that in the winter of 13-14, the anomalous pattern was more like an NPGO or North Pacific gyro oscillation-like pattern, and then it transitioned towards a Pacific decadal oscillation-like pattern by the winter of 14-15. Now, what I would like to hypothesize is that this transition from NPGO-like to PDO-like pattern is a transition that statistically occurs frequently in the North Pacific. This particular transition for the 14-15 anomalies was a particularly strong amplitude one, but there are specific dynamics that add persistence from an NPGO-like to a PDO-like pattern in the North Pacific. To begin addressing, or at least showing that, I want to measure the temporal variability of the anomalies in the two nodal region points here, one in the Gulf of Alaska and in the California Current. So let's focus first on the Gulf of Alaska time series, which is the average SST in this box, and again we find important low frequency variability, and then by 2014 we find these kind of record events that are more prolonged, and so that's consistent with what we've seen. And if we do the same thing for now the California Current or west coast of North America box here, again we find low frequency variability, and then this very huge peak in the 2014-15, so that we have essentially this evolution from the Gulf of Alaska pattern, the decay of the Gulf of Alaska pattern, and the growth of the California Current pattern. So this is essentially the anatomy of the evolution of this anomaly in both space and time. And what we can do now is we can actually look at the temporal relationship between the anomalies in the Gulf of Alaska and in the California Current by computing the cross-correlation function of these two indices, which is plotted here. This is lag 0. These are 20 months forward, 20 months backwards. Now, what's interesting about this cross-correlation function is that it's not symmetric, and there's a side of the cross-correlation function, which is this one, where there's very strong persistence. And this particular side represents the portion of the cross-correlation function where the Gulf of Alaska anomalies are leading the California Current anomaly, which is essentially saying that when the Gulf of Alaska anomaly occur, like in the NPGO-like pattern, then there's a strong persistence into the California Current anomaly, but not the other way around, so that when you have a PDO pattern, it doesn't really transform into some kind of NPGO-like pattern. So now let's address what dynamical explanation could underlie this persistence from an NPGO-like pattern in the winter of 2013-14 to a PDO-like pattern in the following winter. So let's go back to our little anomaly map, and let's focus on the winter of 2013-14. Now we know that this particular anomaly was initially generated by strong atmospheric forcing associated with a well-known pattern of atmospheric variability that Nick Bond had described in a paper in 2014, and this pattern in the atmospheric literature is referred to as the North Pacific Oscillation, or NPO. There's also other literature showing how the NPO in fact drives the oceanic response that is measured by the North Pacific Gyro Oscillation pattern, the SST, which is consistent with what we're seeing in the winter 2013-14 anomaly. But importantly, this NPO pattern is actually associated with an important precursor dynamic of ENSO. And so in fact, when you have an NPO variability in the North Pacific, the trade wind anomalies that occur in the tropical region associated with this pattern can actually generate SST anomalies that feed back onto the atmosphere. And there's a thermodynamic feedback between the ocean and the atmosphere that can actually amplify these SST anomalies and move them towards the tropics. And once they reach the tropics, they can essentially favor the development of an El Nino. And this type of precursor dynamics are well known in the North Pacific and have been referred to initially as the seasonal footprinting mechanisms and more recently as meridional modes. So this is a well-known dynamic. But then when we have an El Nino in the tropics, we also know that ENSO generates teleconnections back to the extratropics. And in particular in the North Pacific, it produces teleconnections that project onto the Aleutian low. And changes in the Aleutian low are integrated by the ocean into the Pacific decadal oscillation pattern, or in other words, the Aleutian low drives the Pacific decadal oscillation pattern. So that essentially, once we have an NPO and a North Pacific gyro oscillation pattern, through this tropical link, we have a persistence onto the Pacific decadal oscillation, because it takes about a year to go from here to the Pacific decadal oscillation pattern, which is what we see now in the winter of 2014-15. So with that said then, this tropical coupling initiated by the NPO could in fact drive persistence in the North Pacific SST and this transition from NPGO to PDO-like pattern. Now what's interesting, as I said, the way that the NPO affects the ENSO system is through a coupled ocean atmospheric thermodynamic feedback that is also referred to as the WESS feedback, which stands for wind, evaporation, sea surface temperature feedback. And the amplitude and growth associated with this particular thermodynamic feedback is a function of the mean SST in the tropical basin. What that implies is that if greenhouse forcing will continue to warm the surface temperature also in the tropical basin, as we have projections showing that, then the amplitude and growth of this mode will increase. That is, the variance associated with this particular system is from a mechanistic point of view projected to change. And so that's something that I think is important to point out as we move forward. So my two final comments then would be, one, that greenhouse warming may actually increase the thermodynamic feedback and as such make these warm events more frequent. And so we have to study these type of dynamics a little bit further, although there are issues related with the fact that climate models do not capture this dynamic very well. Although I will say that in a recent study by Wang et al. In 2014, they've ran a couple climate simulation with the CSM where they showed that under greenhouse forcing, the link between the North Pacific Oscillation precursor and ENSO becomes very strong compared to the controlled run. In fact, it intensifies, which would be consistent with this hypothesis of more frequent events like the one that we just saw. And of course, we know that these type of SST patterns in the North Pacific are very important because they have strong impacts on marine ecosystems. And at this regard, I'd like to publicize a recent study by Kilduff et al. That shows that the NPO and PGO pattern is linked actually to long-term changes in salmon survival. So these are just my comments that I made at this SIGMA workshop, and I hope they can contribute to the discussion. Thank you.